Hi, my name is Emmanuel Etkudo, and I'm currently taking Physics 2211 at Georgia Tech, and this is my lab report on Rutherford scattering. This lab discusses four key topics. The first being Newton's second law, which states that an object's acceleration is dependent on the linear force applied on the object and the mass of that object. Collisions can be defined as interactions between two objects that take place in a short amount of time. And a key thing about this lab is that we should know that an object doesn't have to be in physical contact with another one for there to be a collision. And then also, conservation of energy states that the total energy of an isolated system remains constant and is said to be conserved in time. And also, conservation of linear momentum says that the momentum of all objects involved in the collision is the same before and after the collision, regardless of what happens during the collision. The purpose of this lab was to examine the collision of particles with no contact between them and also to understand the reasoning behind Rutherford's model of the atom. The model we'll be using is based on Rutherford's experiments where he tried to determine the distribution of electrons in the plum pudding model proposed by Thomson. And the experiment consisted of shooting high energy alpha particles at a thin sheet of gold foil. In the initial conditions of the computational code, which was written in Python using script, we demonstrated how the model was created, as well as gave the initial positions of both our particles. We also gave some constants used in our calculations, such as the mass of the particles and the charges the particles exhibit, as well as the impact parameter, which is the minimum separation distance between the alpha and the gold nucleus. Here's the calculation loop of our computational model code. Here you can see that we use Newton's second law and the velocity and position update formula to calculate the net force as well as plot the model on script. Also, we also calculated the system energy changes which were then plotted and will be discussed in the next slide. For the results, here we see the change in energy versus time graph, which is that the kinetic energy of the alpha particle and the electric potential energy are both positive, which indicates a repulsive force between the two particles. It also agrees with our statement on the law of conservation of energy, as the total energy of the system remains constant throughout the entire time of the lab. And also, something interesting to note is that the kinetic energy of the gold particle slightly increased, indicating that it was pushed a little bit by the alpha particle, but too little to be seen in the visual model. Here you see our two momentum graphs also obeying the conservation of linear momentum. And since the change in momentum is equal to zero, then the total momentum of the system didn't change and thus was said to be conserved. Here are some extra questions I tried to ask myself after conducting the experiments. What if the deflection is minimum? What would the impact parameter have to be? I discovered that by playing around with my impact parameter to get a minimum deflection, I'll have to start the movement of the alpha particle 500 times 10 raised to power minus 15 meters away from the gold particle on the y-axis, and for the deflection to be perpendicular it will have to be 10.7 times 10 raised to power minus 15 meters away on the y-axis from the gold particle to get a perpendicular deflection. Thanks for watching.